I would just like to make an announcement about 2 workshops that LSST are organising next year, that data management are organising. One is the first workshop is on LSST community brokers. This workshop, the goal of this workshop is to bring together the LSST project personnel as well as representatives of the science collaborations and proposers of community brokers to open a dialogue around all the aspects of LSST community brokers. So broker interfaces, architecture, technology choices, the selection process, policy issues, etc. The idea is to involve the community and the proposers of community brokers in this process to build up the community broker community for LSST. The workshop will be on the 27th, the week of the 27th of June in Seattle. It's an invitation-only workshop. We have an organizing committee already, which comprises myself and Eric Belm, the alert production lead in Seattle, Melissa Graham, Federica Bianco, Željko Ivezic, Joshua Bloom, Bob Blum, and Rachel Street. So in this, I think that we've got in the organizing committee a good mix of LSST, of science community users, of people who've been involved with brokers already to put together this workshop. So that's the first workshop. Yes, go ahead.
Can you repeat the date and maybe name of the workshop for the notes? Sorry, I'm a little
Sure, I can update the notes.
Fantastic.
Yeah. So that's the first workshop that we're organizing next year. Do I have any questions on that before I move to the next one? With the organizing committee, we're going to get going in the new year once we have the LDM 612, the policy document for alert distribution out. Okay. The second workshop will be in a very similar vein. It will be a workshop on LSST algorithms. This will be in late 2019. We don't have a date for it yet, but we expect around October-ish, late October. The goal of this is to involve the LSST science and user community in the choice of algorithms that LSST will use in our processing. We want to both communicate our algorithmic knowledge to the community and the people who will be doing science with LSST, but also to learn from the community and give people in the community a chance to propose algorithms and to present papers and ideas at this workshop. So this is not meant to be a coding workshop or a code review. It's meant to be a science-driven understanding of the algorithms that we will use for LSST. We don't have a venue for this yet, but we're thinking maybe Princeton, maybe Manhattan at the CCA in, as I said, late October. There will be more details on that in the new year as we start to put the organizing committee together. So do I have any questions on that?
So actually, I have some questions. So who are these workshops open to? I mean, I realize that they're not fully organized, but do you imagine to open them broadly to the community?
So the first one on community brokers, it will be an invitation-only workshop. We are expecting something of the order of maybe 40 to 50 people. The idea is to bring together people, people in the science collaborations and proposers of community brokers. So, for example, any group that puts in a letter of intent for a community broker, we expect to invite representatives of that team to this workshop, either one or two or a few, and we would take recommendations from teams of community broker proposers for other people that they might like to see also invited to the workshop. I think we would want to have good representation from the science collaborations, as they will be the users of the alert streams. I think we probably want good representation as well from follow-up facilities who will be working with the output of the community brokers. This is something that the organizing committee will address in the early year, who we want to invite. For the algorithms workshop, we haven't really looked at that, thought about that yet. It's still a way off, but I expect in a very similar vein, good representation from the science community and users of the LSST data products who have input to the sort of algorithms we should be running.
Thank you. Then in that case, I'm gonna take it away and move to
Should I start sharing my screen with the charts?
I had another announcement before this.
Oh, okay.
I wanted to announce to the project a couple of things, and to the science collaborations also one thing that they haven't heard about yet. To the projects that I'm leading the science collaboration into an application for the CellNet NSF proposal, which is a proposal that is designed to support network-to-network large international collaboration in the development of anything that is necessary to make the collaborations effective. The proposal call is the submission deadline is February 28th at the top of my head, and a letter of intent will go out on the 21st on the deadline. And I will probably reach out to the science collaboration chairs. Of course, we will write it together. I will reach out to probably project as well for content, although we're going to keep it separate from project because this is an NSF-funded proposal, and we think that's the best strategy given potential reluctance on the part of NSF to fund LSST, since they will fund LSST if they see it as doubling on the funds that they've already invested in LSST. So we're going to try to keep it a little bit separate and be specifically the science collaborations, but of course we want the support of project and LSSTC, and I spoke with a few people in project and in LSSTC, and everybody thinks it's a good idea. And related to that, and I don't know if Jeno has joined the call. I don't see her. But Jeno, who's the new director for science of LSSTC, actually brought this up in the first place. That the decadal survey is rapidly approaching, and we don't think it would be a good idea if LSST was silent in the decadal survey process. And so we discuss the submission of a white paper that stresses the imbalances in funding of the US versus international LSST science community, by which I mean the community that is interested in doing science with LSST. So from my point of view, largely the science collaborations, as well as the imbalance between DESC and the other science collaboration that's being funded, if only partially, by DOE. And so indicating that may cause the US to effectively lose its lead in a lot of the science that will come out of LSST. And so this is news to my science collaboration chairs as well. So expect me to also ask you to contribute to this paper. I don't think the scope is very different from what will go into the NSF proposal, so I don't think it will be a lot of added work compared to what you already signed up to do to write the NSF proposal. And yes, I think that's the end of the announcement. Do you have thoughts? Do you think these are good ideas?
This is Michael. I wonder if that white paper, I guess I'm asking a political question, should project personnel sign that white paper, or is it better that it be seen as coming, as it were, purely from the community?
Željko, we talked about this yesterday. Do you want to answer? Do you have thoughts about this? Maybe he doesn't.
Željko's muted or something.
While Željko's finding the mute button, let me just say I recommend you also have a look at the mid-decadal survey. We had a recommendation there related specifically to this. And the CAA meeting minutes, every time that NSF comes to talk to the CAA, we ask about specifically this issue, funding for scientists to do research.
Right.
And the issue of how MREFCs are handled at NSF. So I think if you tag on to those, it could be a good thing as well, or at least cite them. I would suggest you consider
that. Steven, can I reach out to you to actually get the relevant documents?
Of course, happy to.
Thank
you. Send you URLs. Sure.
Thank you very much. And so let me answer on behalf of Željko, if I may. We thought yesterday we converged on the idea that it may be counterproductive if project is prominently featured in the proposal, more importantly, but also perhaps in the decadal survey white paper, and that definitely it should have the very large representation of all the science collaborations, and perhaps project as a co-author, just to indicate that this is under the project's radar and that there is no tension between the project's thinking and the science collaboration's thinking along these terms, but that it should be led, and it should be very obvious that it is led by the science collaborations.
Yeah,
but generally the scientists. But I'm happy to hear if there are different thoughts, and to hear the suggestions, of course.
People often make that incorrect argument that we already received $1 billion of public money and now we want more. But we need to understand it's not the same pot of money and it's going for different purpose. So I think it's better to prevent such questions just by removing visible names from the project, from leadership of these white papers, and have Federica and other science collaboration chairs take the lead, at least in the names that will be put forward, and demonstrate that there are hundreds of people who would like to do LSST science, but the astronomy side of it, non-desk side, is kind of falling behind because they don't have resources to prepare. So if there are no questions for Federica, I think we are ready for Chuck and Leanne.
Are you seeing my screen?
Yes.
We are.
Title slide. Okay. So this is a joint presentation by both Leanne and myself. And it's part of I think this is part of what I would consider a start of a conversation with the science chairs. And it's also part of I think a two-part talk series. There'll be a second part in February that's more geared towards discussing getting access to the commissioning data and how the science collaborations can contribute and participate in commissioning. And so the intent with this talk here is to give the science chairs sort of a big picture summary of what commissioning entails, and with a more specific focus towards science verification, mostly to be used as a backdrop for the next conversation. So without any further ado, if it's going to behave, I just do. There we go. So scope commissioning aims to answer three basic questions, and they are: did we actually build what we said we're going to build? This is what we refer to as verification, and this is really scope that really falls firmly underneath the umbrella of the construction project to do. Does what we built do what we want and expect it to do? And that's validation, and that's also mostly under the responsibility of the project. And then the last question is, do we understand how and why what we build works the way it does? And that's characterization. And that's where I think the science collaborations can actually make a significant contribution, because in some sense characterization is quite open-ended. So on the construction project side, we have to be careful not to overextend our scope. So next, from a more of a technical point of view, the role of commissioning, of course, is to make sure that the physical elements of the LSST observatory come together the way we plan them to come together, and that includes early subsystem integration tests, camera re-verification, some pathfinders that we've scoped out to mitigate risks. The big item here is the system level assembly, integration, and test of the telescope camera, DM, and EPO. That's really our bread and butter, what we actually have to do. The verification of performance and characterization, as we were just talking about, and overall science validation of the integrated observatory. And again, the science validation, I think, is an area where the science chairs and the science collaborations can contribute. There's a bunch of inputs from the project construction side. I won't go down this list on the right-hand side, but there's a number of documents that describe sort of what the state of the subsystems are expected to be in and how those fold into the detailed technical plan of commissioning. So if you wanted to have one chart to see the commissioning in a nutshell, this is it. So it's organized in phases because basically all the hard deliverables from the construction project will have been done when we get into commissioning, with a few very small exceptions. So phase 0 is what we're doing now, what's happening today. It's really planning and preparatory work, both in development of software tools and developing detailed verification tests. That's a heavy activity right now in science verification in collaboration with the data management verification efforts. And then we come to what I call the onset of the real main commissioning activities. That's phase 1. That's an early system testing with CommCam that lasts for about 6 months. I'll have a few more charts on exactly how CommCam, not exactly, but better describes how CommCam fits into the overall science verification strategy. But CommCam is basically replicates many of the interfaces of the LSST Cam, allows us to do a lot of early technical system integration tests. It also provides us an opportunity to start subscale DM pipeline testing. That's then followed by the full system AINT with the actual science camera. I see my time estimation got covered up by one of my charts. So that's roughly 5 months of activities. And that includes getting the camera from Slack, because the camera construction project finishes at Slack with the LSST camera ready to ship. And then commissioning picks up the mantle and gets it to Chile, re-verifies it, gets it on the telescope, makes it work. Last phase is science validation. And we currently have envisioned 2 mini surveys. One is a wide area survey that is really geared towards the validation verification of alert production. And then a second survey, which is more narrow in scope as far as its footprint on the sky goes, but it's meant to test a 10-year equivalent image stack and the data release processing associated with that. And that all gets finished up with the operations readiness review. And that's meant to be a review of the construction team to the agencies by a panel of our peers to say that we're ready to start the survey. Some key milestones in this chart here. I don't want to belabor this one, but what's important for science verification is that there are 3 identified periods where we're going to basically be 100% on sky to the extent the weather allows. And the first one is with CommCam. Next one, obvious, is LSST Cam, and then the 2 science validation mini surveys at the end. And we'll have a little bit more detail to speak to in a moment. The next 3 charts is I just wanted to quickly summarize for you guys what the state of the system is expected to be in functional-wise when we enter into the commissioning phase. So for the telescope and site subsystem, the Summit observing facility will essentially be fully operational. All the in-dome calibration systems will be tested and operational because they're needed by the commissioning activities and the science verification activities. Telescope specifications and ICDs are verified. And before CommCam goes on sky, the telescope team itself will have spent roughly 2 months of on-sky time with something they call the early optical test assembly, IOTA. And that is meant to characterize the on-axis image quality, get the basic active optics control system functioning. And so we expect the telescope system to be delivered to commissioning, performing at a fairly high level. The LSST camera, as I said earlier, plan is to have it fully populated with all 189 science sensors, the full complement of 6 filters. SLAC will be receiving a second rotator, so that mechanical interface gets tested, optimal alignment of lenses, and then a whole slew of other requirements and verification tests will be done. And as I just said previously, the camera construction project ends with the camera ready to ship at SLAC. Data management, which is more tightly coupled to the science verification effort. This is my opportunity to segue to Leanne, but I think the bottom line here is there's a lot of ongoing verification work as DM is being developed using legacy data from a number of different sources, and I'll give it to Leanne.
Okay, so thank you, Chuck. So as Chuck said, commissioning's bread and butter is basically to do the full integrated system verification, the telescope, the camera, data management, and EPO. But before the commissioning team can do that, each of the subsystems has to do its own verification. So we're in this phase 0 at the moment where we're doing pre-commissioning verification of data management, and likewise the camera and the telescope teams are as well, to ensure that our products that go into commissioning have passed a certain set of criteria that mean they can be used in commissioning, and they're ready for integration with the other subsystems. And so we're doing this by building up the data management acceptance test specification. This is document LDM 639. This is based on the data management system requirements document, LSE 61, which is derived from the high-level science requirements on LSST, the LSST system requirements, and the observatory system specification.
If I may interrupt, just as a pointer to the science here, you probably already know the shortcut, but all these documents that are referenced on this chart and elsewhere in these slide decks can be reached by this URL shortcut. It's ls.st/ then the document handle.
Mm-hmm. So as I said, we're in the process at the moment of this phase 0 where we're building up test specifications, system verification, we're building up procedures to do this, we're writing the software to put in place to test data management. And we're working very closely already with the commissioning team, the science verification group in commissioning, to ensure that the procedures we put in place are reusable by the commissioning team, that they can use these system specifications, and that they could possibly even reuse some of our code as well and services. So perhaps just a few more details about exactly what we will do. We will do extensive verification of the data management science pipelines and the data products by making use of precursor data sets and LSST simulations. So for example, HST data, DECAM, ZTF data for doing some of the alert testing, and many other surveys as well will provide very early testing for the LSST algorithms and software. And I show you here just an example of 3 different algorithms that were tested. This is reported in a paper Bosch et al. 2017, where they tested these algorithms for the removal of image artifacts observed in individual visits from co-added data using the HSC data. And so we have a set of these HSC processing campaigns that happen regularly, and we will also step that up with other precursor data sets and alerts as we continue to move towards commissioning. So in terms of the alert filtering service, LSST will provide a simple alert filtering service that will give real-time access to a subset of the alert stream via the LSST science platform. This is a tool, a product that is very much independent of the rest of the system. It doesn't depend on the telescope, it doesn't depend on the camera. And so the alert filtering service will be verified almost extensively and almost exclusively, fully, in DM prior to commissioning by using simulations and precursor data sets. And so in the commissioning period, the LSST alert filtering service will effectively become a tool to the commissioning team for doing alert stream verification. And so we can focus on things like verification of alert stream sizes, we can look at false positive rates, and use this to exercise the integrated system in real time. Many people have asked about community brokers in commissioning and what their role will be. So just to remind people that community brokers are not an LSST deliverable, but they do comprise an essential component of the whole ecosystem. And so without these community brokers, scientists aren't going to be able to access the alert stream, and they're not going to be able to trigger follow-up. So they are a very important part of the LSST system. And as such, our approach towards community brokers in commissioning is that where possible, we will do what we can to include LSST brokers in commissioning. We will define a yet-to-be-determined set of criteria that will have to be met for a community broker to be supported during the commissioning period. This is to ensure that it's worth our time and worth the time of the community broker team. So we'll have a certain set of verification tests that will need to be passed, probably using precursor data sets or a simulated alert stream to show basic functionality, and then we should be able to include community brokers in some of the commissioning work. During the commissioning period, we will provide alerts to enable engineering tests of the broker interfaces. This will happen with CommCam. We will have a sample set of alerts, but with substantial latency. Likewise, 1 month after LSST Cam, we also expect to have a sample alert stream with substantial latency. And during the mini surveys, we expect to be able to provide an alert stream with the latency of OTT1, which is the Science Requirements Document mandated latency. This is currently 60 seconds. So, but if that were to evolve, we would evolve that during commissioning as well. The LSST Science Platform and data access will be used during commissioning as well. We will use the Science Platform to serve the commissioning data to the community, both to the parts of the community who are involved in commissioning, but also and to the commissioning team. This means that we can not only do verification of the Science Platform itself, we can do it using representative test cases, real data from CommCam, from LSST Cam, using representative use cases. And so this should give us a very good testing ground for the LSST platform itself, as well as providing the commissioning team with the tools that they need to commission the integrated system.
Yeah, wanted to add one thing, that the commissioning team already is now heavily engaged in developing our verification activities through the science platform, and we're basically serving DM as a suite of beta testers for interacting with the science platform, because the science platform has to be commissioned too. Right?
Exactly. Yeah. And so one of the ways we're doing this in many ways. One of the ways is that we hold boot camps, data management. Mid this year, we held a boot camp with the commissioning team where it was just basically 3 days of everyone sitting down together, writing notebooks around commissioning activities using the LSST Science Platform. And it was an excellent way for the commissioning team to learn how to use the platform, and for DM to see how people use the platform and where we needed to focus our efforts. We held another one of these boot camps about a month ago in Slack with the camera team, where we had a focus on instrument signature removal algorithms and also training the camera team to use the science platform, the algorithms that we have in data management. And this was very, very fruitful. It raised many issues with the instrument signature removal algorithms, how things are being done a bit differently in the camera team and data management, and is helping to bring us all together onto the same platform, both the science platform and with the algorithms. So we will be holding more of these boot camps in the future, and I would encourage anyone who's interested in being involved in commissioning to come along to these boot camps and to learn how to use the science platform now with precursor data sets and simulated data. Just to give you a bit of a taste, some of you have probably seen this already. This is the Firefly Portal aspect of the science platform, where you can see here an image with detections on this image. You can see then the table in a database of the detections with coordinates, positions, information about deblending. So these are the output of the science algorithms. And then you can see interactive plots being made from different columns in the database based on the data in this image. So the Firefly system gives you a way of visualizing this data and also manipulating it at the same time. There is the notebook aspect, which many of you might be familiar with already. This allows you to write Jupyter notebooks to access the data, typically held in a Butler repository, to write notebooks to access this data and to analyze this data, do visualizations, to manipulate the data, produce plots. This has been very successful so far, and we continue to work on building up the notebook aspect of the LSST Science Platform. And on that, I will hand it back to Chuck.
All right. Let's see. Continuing on, just a little bit more about how we see the scope of science verification and what it is that we, the project, are committing to do, or what not just the project, but more globally, what we envision that we have to do. And first and foremost is that we need to determine whether we're meeting the specifications that are defined in the SRD for the survey performance. There's some other system performance metrics that are described in Section 2 of the SRD that are not formally normative, but we certainly want to investigate how well the system performs against those metrics in the context of the 4 primary science drivers. And an example is photometric redshifts or deblending, or there's a number of things that and there may be other metrics that the science collaborations can envision that they would be interested in characterizing as part of the commissioning effort on their own to evaluate the system performance. We also need to do what we call the environmental dependencies. So how, not just that we need to validate the system performance under nominal conditions. We also need to understand how it performs in the edge cases. And then there's a part that's called technical optimization, right? So if you think of the LSST system as a big giant control box, there's many different knobs on that control box that can be tuned and adjusted to optimize the performance and the science output. And we need to start that process as part of commissioning. But of course, that goes on indefinitely all the way through operations. And then it's critical for us to document our system performance. And then, again, once we verify the performance of a property of the LSST, we want to continually monitor that performance over time throughout the commissioning phase to understand how that performance depends on these things that I just mentioned beforehand, the environmental and the technical conditions of the system. And then validating that the data delivery is being done correctly, data products that we've committed to are actually being produced, and that the access to those things, as Leanne just described with the science platform. Probably don't need to go through this in great detail. I suspect all of you are familiar with the science requirements, but basically the things that we have to verify and validate are 14 single visit properties and 10 full survey requirements and properties of the survey data. And these will require detailed analysis. And I think, again, some of the analysis aspects is where we could use some additional support from the science collaborations. Leanne already mentioned verifying the science pipelines as part of this program. I just wanted to point out in this flow chart and the one you saw previously in Leanne's charts, there's a total of 18 calibration products that need to be verified, 14 alert production pipeline components, and 26 DRP pipeline components. So we're designing verification tests around each and every one of those. And many of those verification tests are complex. They're not just a simple make this one test. To test a component may require many subtests to be rolled up and then verifying that one component. This is a little bit more detail on the characterizing the other SRD motivated metrics. This is not an exhaustive list, but it gives you some ideas of what we've been thinking about. And I have to remind myself that I have to give a hat tip to Keith Bechtol, who helped. These are mostly his slides from our recent commissioning review. But they include things like object detection, completeness, star-galaxy separation, galaxy photometry for photometric redshifts, difference imaging, low surface brightness features, weak lensing, null tests, crowded fields, deep blending, et cetera, et cetera. I'm sure the science collaborations can come up with many more metrics. And the purpose is to reveal, right, so the purpose of including this stuff is that, as we all know, that LSST is going to be a systematics limited science experiment, and digging into the more subtle dependencies and the subtle issues is the way we're going to push the systematics floors down on our performance. On with that. So the way we're planning the science verification of LSST, starting with CommCam, is to go from starting simple, and as we continue throughout the entire commissioning process, to grow the complexity at each stage. So we start with CommCam, go with LSST Cam. We are allocating about 25% of the total time throughout commissioning to deal with engineering activities, particularly during the phases with CommCam and LSST Cam. This is just based on my personal anecdotal experience that as you go, you develop punch lists of things that you discover. And if you don't allocate dedicated time to address those punch lists, they never get addressed. So by increasing sophistication, we start with calibration products, move into single visit performance, image stack performance, and then some of those other more science-driven metrics that I mentioned earlier. And this kind of progression repeats itself both with CommCam and then also with LSST Cam, and the primary difference is the scale of the data. Let's see. So Keith and I and the commissioning team and others, I think some on this call, I think Robert was involved in the planning of some of this as well. This is kind of the cartoon visual for the broad activities and the data collecting strategy we have. So the columns here represent the different phases of commissioning. The rows indicate sort of within that a given phase a collection of activities or an observing program. So for each one of these, the gray boxes is more technically oriented. You know, the physical optoelectrical integration of either CommCam or LSST Cam. And then there's the blue boxes are sort of dedicated observing campaigns with different emphasis. And then the green is the final science validation surveys. And there's more to come coming up. So with CommCam, so this will provide us our first opportunity for many of the tests, both technical and science pipelines. We'll do repeated imaging of several fields and multiple bands at different air masses, source densities, etc. Where those fields are, that's another area where the science collaborations can contribute. We'll explore a range of environmental conditions as time allows, and then we currently have planned a scheduler test towards the end of CommCam to validate that the scheduler produces the right observing sequences as predicted by the simulations. Then I wanted to dive in a little bit technically. I'm not sure how many of the science chairs know exactly what CommCam is, so I'll spend a few moments here summarizing that. So it's a single raft camera. So the LSST Cam is made up of 21 science rafts. Each raft has 9 CCDs arranged in a 3x3 square. It's 144 megapixels. Currently planned for CommCam is to populate with engineering grade devices. There is the possibility of getting a raft that has some low-end science grade is what I would call it. These are near science grade devices that didn't quite pass the threshold to be put into the main LSST Cam focal plane. It'll have a 40 arc minute field of view. It has the same spatial sampling that LSST Cam has, so that's 0.2 arc seconds per pixel. We will have all 6 filters for CommCam, UGRIZY. In fact, today, as we speak, we have 5 of the 6 in hand. But an important limitation is that only 3 of those 6 filters can be on CommCam at any given time. And there's not, right now, there's no plan to switch the complement of filters in the middle of the night. And for technical reasons, we got to have the same mass properties of the LSST Cam, so the telescope behavior should be as close to what we would expect with LSST Cam as possible. So some other limitations to be aware of with LSST Cam. We elected not to anti-reflection coat the lenses. So that means that the ghost strengths will be slightly higher and the throughput will be slightly lower. When we're using CommCam in a full frame mode, guiding will not be available, and so we will be relying on open loop tracking for most of the science-like imaging that CommCam will do. And the last one is the closed loop wavefront sensing that we have designed into the LSST Cam will not be available in full frame imaging mode. And we will have to then compromise some of the observing sequences to pause periodically to take some wavefront data and update the adjustment of the optics. So basic objectives is focusing on electro-optical tests with CommCam, engineering, interfacing, instrument signature removal, and then the first on-sky data after that. But things that we'll be doing with CommCam is build and test the pointing model, build and test the active optic system lookup tables, raster single fields across the detector to do illumination corrections, to validate our determination of the illumination correction using the internal dome calibration systems, color term estimation, astrometric solutions, etc. Repeat observations to test stability of photometric and astrometric solutions and statistical precision. And again, where these fields are, where we conduct these tests is not yet engraved in stone. And of course, it will depend precisely on the exact scheduling of those observations and what fields are available at that particular time of year. We've talked about having a reference field at the celestial pole that we can then look at systematics as it relates to the camera rotation on the telescope. Observations of that reference field through different amounts and kinds of clouds to see how well we're dealing with gray extinction corrections, etc. There are many other tests. This is just a subset that we can do. Okay, so then once the technical phase of CommCam is complete, we go into what I call the sustained observing phase with CommCam. We have one observing campaign that is meant to evaluate the key performance metrics. These are the KPMs data management has derived from the science requirements and the ones that they have been verifying up until this point with legacy data. But this is now the first time they get to start verifying those things with real LSST data. The image quality of CommCam is good enough that we can start doing meaningful PSF ellipticity tests. We'll start doing transient and moving object detection and linkage. But again, on that last point, that will be done in a batch processing mode kind of way. So it will not be done in real time or with the 24-hour delay that the real survey will have. This campaign, just again, these are straw man proposals at this point. So just to give you an idea of the capabilities of CommCam, so 20 fields times 5 epochs times 5 visits times 6 filters, that's 3,000 visits, and that'll take about 4 nights. If they're all nice.
Good nights.
Good nights.
Yeah, no rain, no snow, no sleet.
Yeah. So we're going to need fields that contain absolute photometric calibration standards. We want fields that have ground truth for spectroscopically determined photometric redshifts. We want to be able to do this through a range of air masses, source densities, etc. There's a bunch of other stuff that we can think about doing. The second observing campaign with CommCam is a 20-year depth testing. That means basically taking a small number of fields of order 10, and if we had a month's worth of observing on 10 fields, we can get 1,700 visits per field, and that's the equivalent of 20 years of survey. And the purpose there then is that once you have that cube of data, you can slice it up in many different ways and start poking at the systematics in the performance metrics. I'm sure it'll also cover a range of environmental conditions that we can explore as well. From a science point of view, one thing that is interesting to me is that the cadence of these observations will be unlike anything we ever do during the survey from a time series point of view. So there, it might be real interesting to think carefully about which fields we want to observe. Last observing campaign with CommCam is scheduler testing, and this again is to do basically spend 4 weeks to run the system driven by the scheduler. So in a survey-like way, and make sure that the scheduler is responding to what I would call the tactical response, less so the strategic response, because there's all these other inputs. How do we deal with clouds? How do we deal with the moon, et cetera? We need to verify all that stuff. Coming towards the end here, early science validation with LSST Cam. Basically, it's a redo of everything we've done with CommCam. Hopefully, with the experience of CommCam behind us, it's more efficient. So again, we'll do key performance metrics, and this time now, because it's a full field of view, we're focusing on field dependencies across the 3.5 degree field of view. Same thing, we're planning for 20-year depth test with LSST Cam. Again, I think that would be, from a science perspective, a very interesting data set. We end commissioning with the science validation mini surveys. Again, we envision that there will be 2 of them, each of them 6 weeks in length total. A wide area survey that is split up in 2 3-week phases, and then a full depth survey lasting 6 weeks. So the first one is the wide area, and this is really aimed at validating template building with the data release processing pipelines, alert processing, real-time alert generation, and monitor the survey progress over a wide area, test the observation simulation. So an example for how we can do this, how we can deploy this wide area survey, we picked 1,600 square degrees, 15 visits per position, 6 filters. Do this over 2 phases, that's 30,000 visits, and that's roughly 40 nights total. So the idea then is the first phase would be observations for template generation. And then while the templates are being generated in the data process, which will take some time, we would then go on to do the second mini survey, which is coming up next. But then once those templates are generated, we would go back and observe the same footprint for 3 weeks with the focus on producing the alerts. The second survey is to, again, as mentioned previously, is to take a limited number of fields to 10-year depth to test the data release products at full survey stack within that footprint. Allows us to do some data quality characterization beyond the SRD. Again, we can do some template generation, but it's not quite the same as the templates that we're testing in the first mini survey. Again, a straw man idea. If you took 300 square degrees, 825 visits across the 6 filters, that comes out to about 30,000 visits or about 40 nights. And again, we want to select fields that overlap with external reference fields, use the scheduler to optimize data quality across the field, and other things. Coming now really to the end, here's our current forecast dates for what I call the key data delivery milestones. So the first one coming up is the start of on-sky data from the auxiliary telescope. It's currently forecasted for August of 2019. CommCam will start on-sky and calibration data in October of 2020. The sustained observing programs that I just summarized are scheduled to start in February of 21. And then LSST Cam goes on the telescope and starts early on-sky testing in July of 21. And then the sustained observing campaigns leading to the mini surveys starts October of 21, and the mini surveys start 2021. And our current forecast for the operations readiness review is March of 2022. Last chart. So as I indicated at the beginning of this presentation, the general data access policy to commissioning data, that's the subject of another scheduled talk in February 2019. But currently, what we're estimating that we can subscribe to is that approximately 3 months following a given commissioning phase, i.e. CommCam, LSST Cam, or the mini surveys, we would release the images, and then approximately 3 months after that release, we would release the catalogs for those images. Now, the caveat here is this is sort of, or I would take this currently with a somewhat of a grain of salt because the policy isn't really finalized yet. It's contingent on my colleague Bob here, that's sitting to my right, on the ramp up of early operations funding and available resources. Basically, the release of commissioning data does not fall under the scope of the construction project. That's on early operations support. So hopefully between now and February, we'll have something a little bit more definitive to say about how the science collaborations can have access to the commissioning data. And on top of that, something more definitive to say about how the science collaborations can participate in the commissioning process. Well, I think I'll stop because that's the end.
Awesome. Joko, if that's okay, I'll take the microphone. There's a couple of questions from people that I saw in the chat. Aparajita, who is one of the strong lensing chairs, is asking about the data management bootcamp. So that's what Leanne was talking about. I also have questions related to that. Are international collaborators allowed to participate? Do you really mean it when you say that you invite anybody that wants to go to participate? Because that may actually be a lot of people. And how are they advertised? How do we know about them?
Okay, all very good questions. So I'm trying to get back to my Blue Jeans window so I can see you guys. Oh, I'm still sharing my screen.
Yeah.
Stop sharing. There we go. Now I can get to the chat window. There we go.
Okay, how do we advertise? So concerning the DM boot camps, the question is, are the DM boot camps open to international collaborators too? How are they advertised? So at the moment, we've been running these on a bit of an ad hoc basis. The first one we ran with commissioning because the commissioning team wanted to learn about the science platform, how they could use it for commission. It was a great success. And then Steve Ritz said, well, we want to do one of these for camera as well. So they're great. We're going to do one for camera too. We're going to try and get the camera and DM team on the same page. So we've only run 2 so far, and they've been a great success. And what I want to do now is push them out further to involve our collaborators, both international and the US, and to get people using the science platform. So we don't have a schedule yet. We
should remember there are also tutorials we've run at LSST Europe. We've run them at LSST Chile. We've run it at AAS. So it's not clear to me you want to run a boot camp for international collaborators exactly. It's a little bit more focused, right? The tutorials are much more accessible.
So we don't have a schedule, we don't sort of advertise these. We have a lot of resources, and we do look to continue these boot camps as we go forwards.
Yeah, I'm just saying they've asked about boot camps because you mentioned them. Yes. We shouldn't forget there are tutorials with hundreds of people, which we have run on several occasions.
Right, and so it is my intention to try and organize a little better the fund, if we, especially, pending availability of funding, try and organize this a little better so that we can invite somebody to give those tutorials at the various science collaboration meetings that are a little bit more contained. I find that when the tutorials are run in very large venue, like, I don't know, LSST Europe, gets very difficult. Everybody has a different starting point. And I think it's very hard for you all to do it in a way that, that most people get something out of it. It's just very dispersed. So,
yeah, I think that's a very good point, Federica. The one that we ran for the camera was very much focused around certain themes for the camera team people, and it was very successful because of exactly that.
Right.
So I'd be very happy to try to set up these little boot camps at science collaboration meetings, for example.
So that's something that we can actually submit a proposal to the Enabling Science call to support, specifically the support for the project people to travel to science collaboration meetings to deliver these boot camps. TVS has done it. We had and Bobber come to our meetings, and Lynn before that. But not every science collaboration has it. Maybe we can submit a separate proposal that supports specifically that.
Great.
Yeah, we are running out of time, so let's go quickly through the questions, and if needed, identify people who will take it and discuss details, like this one with boot camps. You can take it offline and then make a plan for how to deliver it.
Michael had a question. Do you want to ask it yourself?
So I was just asking, the question was whether with all the tests that are being carried out in commissioning, many of them will make sense to continue those kind of tests through operations. As it were, does the PSF continue to be good? And I know the QA is thinking about that at some level, but is there a mechanism by which during commissioning the QA tests get augmented throughout operations?
Short answer is yes, Michael. That's what the DM Square team is working on.
Yeah.
And they are developing a test and monitoring framework that would allow, say, if I develop a test in a Python notebook, that it can get pushed into that framework and just get rerun on a routine basis. So that's, I think Leanne could probably say a lot more about.
Yes, I think that the test suites that we're going to be building up for the acceptance testing for data management will be test suites that can be run at any point, at any time. So if commissioning gets a new set of data, we can run these test suites. We will share a lot of this with the commissioning team. So our goal is that the software will be designed in such a way that the commissioning team can build upon this to go beyond the scope of just data management, but using components from the data management system.
But the technical infrastructure for running these tests, monitoring them, and reporting on them, that's a deliverable by DM. And that's, I've seen a recent prototype from Frosty and her group that I'm very impressed with. And I think
this is using a new time series database to show you the time evolution. So you can run a set of tests and you can run them again and you can see how they evolve over time.
The idea of using these Python notebook-based templates that then, that template is a test and it gets just rerun and version tracked and time history tracked, etc. So.
Okay, thank you.
So the next question, can we share these slides with our science collaborators? I believe these talks are public once they're on the website.
We always ask for each specific talk, but if you and Chuck don't have an objection, this would be awesome to be posted with the other ones.
I have no objection. Now, Jelko, do you have an opinion?
I have no objection.
Awesome.
Good.
And the video will be posted as well.
Right. It will take a few days and then everything will be public. It depends on CommTeam how fast they are.
Tom Loredo is asking if the release mentioned are only for the science collaboration or will the data be public?
So when we talk about releasing commissioning data, we're talking about public releases.
Public here means those people with data rights and not the entire world.
Yeah, however data rights are ultimately get defined, yes.
All right, and so I have a question then if nobody else, which is I want to encourage you to still talk to the brokers and the TVS Science Collaboration in particular about all the all the scientists that are thinking about transients to understand whether there is space to have at least a partial release of the alerts in real time so that the rest of the system can be tested, or in close to real time, or some sort of mock version of your actual production pipeline alert system, so that the brokers can be triggered and then the telescopes can be triggered, and we see if we can actually get the data that we need to on alerts.
Will do. We'll investigate that. Right now, the computing processing services needed for that are coming online later than maybe is ideal for this particular instance.
I understand. Right.
If there are no questions, we are 5 minutes over. Thank you, everyone.
Maybe let me ask, so if somebody in the science collaboration has a fantastic idea for commissioning along the lines of what you said, like, for example, a perfect field for you to test on, what is the process to submit this idea to you?
So that's a good question, Federica. Once upon a time, in a place far, far away, at a community workshop, I presented a web form where people could submit suggestions, and I was wanting to collect, through that web form, various ideas for either RA deck on the skies, a particular cadence, or whatever. And maybe I would turn the tables a little bit to you and ask what from your perspective would be the most effective way for you the way that the science collaborations would want to collect this information. I would love to get information.
I think that if web form is awesome, it's a very good way to do that. Maybe you and I should talk about how to distribute that form to the science collaboration, make sure that everybody in the science collaboration is aware of that, and maybe even see if it should be only accessible to the chair so that you have a level of sanity check before it gets
I will take an action then is on my end is I will resurrect that old web form.
Yep.
And then maybe you, myself, maybe even Jelko, we can iterate on the content of that web form to make sure it has the right kind of, it's asking the right questions that where the science collaborators can contribute to.
Perfect. Thank you.
Thank you.
More questions? First time, second time, third time. Not happy holidays to everyone.
Happy holidays.
Bye-bye.
Thank
you. Thanks a lot.
Bye for now.
See each other at WAS.
Thanks so much.
Indeed. Thank you.
Joy, bye.
Bye.
Jelko. Nice, good.